And when we talked about heat, we said heat is the energy transfer, and there are two things that can happen the when we apply when we supply heat energy to a system. It can either increase the temperature uh, within a given phase. For example, uh, if you increase the temperature of water, the sorry if you supply some energy in a water, it at a certain temperature, it can increase the temperature and remain at the same phase. This is also liquid, and this is also liquid, so basically it's only changing the temperature. For example, in this case, from 10 degrees Celsius to 20 degrees Celsius, or sometimes it can also change the phase. For example, this is 90 degrees Celsius, and it reached 100 degrees Celsius, and the energy we added more energy, and it starts evaporating, meaning it liquid is converted into uh, gaseous form, which is phase change. We call it phase change. And the heat energy required to change the phase from one phase to other phase is called latent heat. We can see in the figure in the right here, there is ice here, and the energy heat energy is added to the system, and the ice is the internal energy of these particles that are made up that the ice is made up of. The kinetic energy is increased, and it changed its phase from solid phase to liquid phase. And as we keep adding energy, it evaporates and converts it from liquid phase to gaseous phase. And this is called the change in phase. From ice to water is melting, and the change in phase from liquid to gas is evaporation. And we also need to know that we just said that the the energy required to change from one phase to other phase is called latent heat. And when we have this ice, and we want to convert it, changes from this phase to liquid phase, it will absorb some energy without increasing its temperature first. Meaning, we have this ice block, and this is at 0 degrees Celsius, and it is we added some heat. Then this is now liquid. So the first, this added heat will change the phase from solid to liquid, and it will still remain at 0 degrees Celsius. And then only, if we keep adding heat, it will increase the temperature of water, for example 10 degrees Celsius. So the first, the latent heat will change the phase without changing the temperature. The temperature of ice and water will be 0 degrees Celsius when we are talking about uh, latent heat. And the same will be the case, for example, if we are if there is a condensation of this water vapor, from water vapor to liquid, this is a condensation. uh, First, the latent heat will change this temperature of this sorry latent heat will change the phase of this gas to liquid. And if this is at 100 degrees Celsius, then the temperature of liquid will be 100 degrees Celsius as well, and if you keep removing the energy, then gradually it will uh, decrease the temperature. So first, the latent heat will change the phase without changing temperature in both, whether we are applying some energy or we are releasing some, or the system is releasing energy. And in this figure we can see, if we are melting from ice to the water, we need to add supply some external energy, and from liquid to gas you need to add energy. However, in the opposite direction, if you want to convert from a gas form to liquid form, uh, the system will release some energy, meaning we are removing the energy from system, and converting from liquid to ice also releases energy when we are freezing. And the each method has a different name. The change in phases for each case has different name. From solid to liquid is called fusion, and we generally called the latent heat as latent heat of fusion. And this fusion includes both solid to liquid and liquid to solid. And then we have vaporization, and then we will call it latent heated vaporization. And this is the this is the phase change from liquid to gas, or from gas to liquid. And there is also the phase change directly from solid to gas, or from gas to solid, and we call that process sublimation. An example, for solid to liquid, liquid to solid, we are all familiar in our day-to-day life. For example, from ice to water, water to vapor, vapor to water, and water to ice, we are already familiar. And for sublimation, one very good example is dry ice. Basically solid CO2, carbon dioxide, it changes. We have this dry ice block, it will directly change to gas without changing into liquid first, and that process is called sublimation. Sublimation. And the latent heat in this process is called latent heat of sublimation. And the temperature required to reach this fusion is, if we are moving from ice to solid to liquid, the temperature should be at a melting point. And if we are if it is changing temperature, phase from liquid to solid, it has to reach freezing point temperature. Similarly, from liquid to gas, uh, boiling point boil it has to reach the boiling point, and from gas to liquid it has to reach the condensation point. And as we talk about evaporation and condensation, let's also define that first. Evaporation, energy required to overcome phase cohesion. For example, if we are interested in evaporation here, liquid the liquid in the liquid form, the intermolecular attraction between this particle is high. Intermolecular attraction, also called cohesion, is very high, and the latent heat is required to break this cohesive force. And in order to do that, we have to supply some uh, external energy to overcome this phase change. higher energy molecules near the surface can then escape. So basically, we have been saying this: when they are in motion, these particles are in motion. As we apply the energy, uh, the particles with high energy near the surface will escape from this cohesive force and change the phase from liquid to gas. And for the condensation, say we have this water surface here, and there are some water particle, and this some particle, sorry, it's not water particle, this gas particle, water vapor particle, and some of this particle will lose their kinetic energy, like we said in previous slides, where we said the average velocity of these moving particles are uh, the sum of the velocity of these particles is very low, and most of the particles move at the average velocity, and some of the particles are moving at very high velocity. So some of these slow moving particle will lose its kinetic energy and can merge uh, in the liquid, changing its phase from this gaseous phase to solid liquid phase, and we call that process condensation.